All right, cross products symbolized by the fact that there's a cross. They're also called vector products because what they produce looks a whole lot like a vector. Technically, it creates an axial vector, what used to be called a pseudo vector. However, for anything that we're doing in this class, you can treat it like a vector. It looks, smells, and tastes just like a vector, so you don't need to figure out how are those different, but this deals with reflection properties. There's one property in particular that vectors have that these do not, or that these have that the vectors do not, but that is beyond the scope of this course. This is also called an outer product. And the deal with the cross product, if you think about that, a cross is basically two perpendicular line segments. And so cross products care about perpendicular. So when I multiply, I want to multiply them so that the perpendicular parts survive. So if I have a vector here, A, and a vector here, B, and I want to know what is the magnitude of A cross B, well, I figure out how much of A is perpendicular to B. So I would break A up into its components. I have a certain amount going to the right and a certain amount going up. This part that is perpendicular to it is A times the sine of, if that angle there is theta, A sine theta. And so the magnitude would be A sine theta times B, the magnitude of B, which ultimately is just AB sine theta. So the magnitude is that. Now I have not given a direction yet, and we know that it does produce a vector. So if A cross B equals C, then C is equal to AB sine theta. But what is the direction of C? And for this we bring in the right-hand rule, generally abbreviated as just RHR. Right-hand rule is you put your hand in the direction of the first vector, which is A, and then you want your fingers to bend so that they bend the easiest way towards the second vector. So if A is pointing that way and B is pointing this way, so A is this way, B is that way, I want it so my fingers will bend the easiest way to get to B. My thumb points downwards, away from the camera at the moment. So if I set up a coordinate system, I, J, and then K coming out of the board, then the direction, then C would be A, B sine theta in the negative K direction. And again, the minus sign is put out front, even though it's indicating that it's a negative K. So if I take two vectors C and D, what is the direction of C cross D? Well, C is that way, D bends is over here, and so my thumb points downwards. So that would be into the page. So the direction into the page. Now notice if I did D cross C, that direction, well, D is pointing off this way, C is going that way. So I bend my fingers the quickest way, my thumb points upwards. So this is out of page. So the commutative property does not hold because even though the magnitude is the same, the direction is completely opposite. Just like if I push on a door from one side of it, I get a completely different result than if I push on it from the other side. Now, in terms of this, there is what I refer to as the right-handed coordinate system, and I've made reference to it before. If I have I that way and J that way, then I cross J, that's I cross J points upwards, I cross J equals K. This is a right-handed coordinate system. Coordinate system. It is the traditional one that is used, so K is outwards. So we symbolize that as a review, that a dot indicates out of page. Generally circle it. And then into page is the X. And the memory trick is the arrow. If an arrow is coming at you, you see the point. If it's going away from you, you see the feathers. And yes, I know, arrow feathers do not look like that. It's a memory trick. So I cross j is k. Well, what's j cross k? Well, j is that way, k is up, so I bend my fingers upwards. My thumb points off to my right, which is in the I direction. K cross I. Well, k is up, I is off to the right, and thumb points this way in the j direction. Now, I do want to point out here, for all these are right-hand rules. This is not dominant hand rule. I've had left-handed students in the past who have had issues with this. They eventually do figure it out, but do recognize that we are dealing with what is called a right-hand rule regardless of your dominant hand. Now, another way of looking at this is if I put IJK, I could put K again, but if I'm going in this direction right here, so this is just a repeat of the first two. It's like you're going around the corner. If I'm going to this direction, it's positive. So I cross J is K, J cross K is I, K cross I is J. If I go this way, it's negative. J cross I is negative K, I cross K is negative J, K cross J is negative I. So now we can do an actual cross product here. So if I have 5I minus 3J plus 2K cross 7I plus 5J minus K, minus 1K. Well, I can do this by distributive property. So that's 35 I cross I plus 25 I cross J minus 5 I cross K. Notice that my order here is the same order as I have up here. That was the I cross those things. Now the J cross I, so I got negative 21, J cross I, minus 15, J cross J, plus 3, J cross K. And now this one, I have 14, that's positive, 14, here we go, 14, K cross I, plus 10, K cross J, minus 2, K cross K. Now let's simplify it. Now in terms of simplifying, well, I cross I, how much of one vector is perpendicular to another? None of it. So this is 0. That is 0. That is 0. Now we're over here. I cross J is K, so this is 25K. Minus 5 times I cross K. Well, if we go back to IJ, Ij, that's the positive direction, and that's the negative. I cross K, I'm going backwards, so that is negative J, negative J. Here, J cross I is negative K, so that's negative 21 times negative K, plus 3, J cross K, which is I. Down here, so then plus 14, K cross I, that's in the positive direction, so that's J. Plus 10, K cross J, that's in the negative direction, so it's negative I. And now you combine like terms. I got 25K minus, that'd be plus 21K, so I have 46K. My J term, I don't know why I'm doing this backwards, but I got 5 and 14, so I have 19J. And then here I have 3 minus 10, so negative 7 I hat. And that is the cross product. And that's how you do cross products. This is another way of finding a cross product. This uses determinants. If you've used determinants before, then this is the technique that's sort of geared towards you. If you have not used determinants before, then you can either find out from another source or you can just ignore this. Or you can ask me and I'll be glad to go into more detail. But for the most part, this is for people who already know how to do determinants. And so you set up, the first row is I, J, and K. And then you take these numbers right here, 5, negative 3, 2, and then the coefficients here, 7, 5, negative 1. So these are the coefficients of I, 5 and 7, the coefficients of J, negative 3 and 5, and the coefficients of K, 2 and negative 1. Order matters. This is the first vector. This is the second vector. When you do, then we're actually do the matrix. So you start with upper left-hand corner. There are other alternate ways of finding determinants. This is just the simplest in my opinion. Start in the upper left-hand corner, I hat, block out that row and column, and what you're left with are those four numbers there. So I'm going to multiply -3 times -1, which is 3. Then I'm going to multiply 5 times 2, so it's minus 10. Minus j hat, because we alternate signs as we go across. So then j hat, negative, and then block out that row and column. And so I've got the 5, 2, 7, -1. So 5 times -1 is -5. 7 times 2 is, so -5 minus 7 times 2, which is 14, plus k, because again, alternating signs. Block out that row and column, and I have 5 times 5, which is 25, minus multiplying 7 times 3, or -3, which is -21. And what you're left with is -7 I hat. This is -19 times -j, so plus 19 j hat. And then plus 25 minus -21 is 46, plus 46 k hat. Again, it's an alternate method for those who might want to latch on to that method.